So this unit's going to be about adding to our travels with standard position that we took in Math 20-1. We're now going to review that, but we're also going to, in Lesson 2, talk about radians. We're also going to develop some equations of something called the unit circle, but most importantly, we're going to solve some problems that use trig ratios and actually apply this, because trig is one of the most applicable math skills that we have. So to review, we talked about some notations in Math 20, where we no longer just dealt with simply right-angled trig, and SOHCAHTOA was not the only thing that we had, right? We also had angles in standard position, and we need to be aware of those terms of reference angles and reference triangles and so on. So a rotation of an angle from an initial arm, right? An initial arm is always on the positive x-axis, right? So on the positive x-axis, if you rotate in a positive direction, you are rotating in a counterclockwise direction. The angle shows an angle said to be in standard position. A positive rotation angle, as you can see in the diagram, is rotating clockwise, and you can rotate as much as you want, counterclockwise, and you can rotate as much as you want in that direction. It doesn't matter how far you rotate, that's all positive rotation. And the same in negative rotation. If you go past 360, you're now getting into things that we'll talk about in a second, coterminal angles, but you can rotate as much as you want. All of that is negative rotation. So now I want you to take a minute and sketch those angles and then come back and see whether you are correct. So sketch 290, 135, and 750. You don't need a protractor, just sketch them and come. All right, so if you are looking at example 1, 290 is obviously in quadrant 4, and we haven't talked about this, but it is 70 degrees away from becoming 360. So there's a special angle right there that's always to the x-axis that I'm drawing in red. We never consider the angle at the y-axis, but that angle is something that we'll talk in the next example about, the reference angle. Minus 135 goes in a negative direction, and it's 45 degrees away from becoming 180. And lastly, 750 is 2 full 360s plus another 30 degrees from 360, right? So this angle right here is 30 degrees, right? Continue on to example 2. In example 2, it asks you to consider a point, and in each case, draw the angle in standard position. So now you need to draw a reference triangle. And so in the first example, you would simply, to draw that point out, you would simply draw that in quadrant 2, because obviously minus 3 and 4 would go left 3 and up 4, and there would be your angle theta. And theta is always measured from that initial arm. So that would be your angle in standard position theta. And inside your reference triangle that we've talked about in Math 20, your opposite side is 4, your adjacent side is 3, and your hypotenuse is 5. And I just did Pythagoras' theorem. Now you do question B, okay, and draw that triangle as well. Okay, Math 30-1, so now you've done, again, there's your diagram for B with minus 7, and that would be your adjacent side, and minus 2 would be your opposite side, and that creates a reference triangle that we can see right here. And I want to calculate my hypotenuse, so I did that by Pythagoras' theorem, and I got root 53. Over here, I want you to remember your Math 20, and I'm doing more than the question asked you to do, obviously, but the sine is minus 2 over root 53, the cosine is minus 7 over root 53, and the tangent is minus 2 over minus 7, which gives you just positive 2 over 7. So those are my trig values. If somebody asked me, well, what is theta? How would I find it? Well, I would find out my reference angle. And you can see that I've declared it 16 degrees. How did that happen? And that's because I can take any one of these ratios, don't type in the negative, and just go inverse sine of 2 over root 53, or inverse cosine of 7 over root 53, or inverse tangent of 2 over 7, and you will get 15.9 degrees, which is 16 degrees, and therefore your angle theta is 196 degrees, okay? Just reviewing. Now we're going to talk about rotation angles. We've got rotation angles of 150. Well, that's great. We kind of did that already. So that's 150 there. 210 backwards, that's in quadrant 2. And obviously 510, we're going around and we're meeting up there in quadrant 2 as well, right? But for every angle that you have, you'll notice that they all stop in the same place, and they all stop with the same reference angle. The most important angle that we have is called the principal angle, because for every angle, if I sat Morgan in a chair, we could spin her around and stop her in the same place, kind of like spin the bottle or whatever, right? We could spin that person around and around and around, and they always stop in the same place. They're going to spin until they get sick, but we could stop them in the same place every time and ask them how they feel, and maybe ask them to stand up and see if they can walk. But the point is that there's an infinite number of, and if I just do it here, I mean, how many times could I spin around and end at the same place? Well, I could just keep going as many times as I want. And in the end, as long as I stop in the same place, I've got the same reference angle. All of those angles are called coterminal. And the most important angle is the one that we started with, which was 150 degrees. Because that is considered the principal angle of all those infinite sets of angles. So in these diagrams, 150 is the principal angle. The infinite set of angles that you have can be written by simply putting the principal angle plus n times 360, where n is an element of integers, okay? And that's what this statement here is saying. So if you want to write the set of angles coterminal with 150, you simply say, oh yeah, 150 plus n times 360. But you must say n is an element of integers, because if we spin Morgan a halfway around, she doesn't stop at the same place. So if somebody says, hey, what's the family of angles that stops at 150? And all you write is 150 plus n 360, you haven't answered the question, because if n is allowed to be a fraction, like a half, then you don't get to the same place. Okay, so this little piece here, that's the piece that most people don't put in because they aren't really paying attention, and they don't see the detail in math that n 360 doesn't mean a full 360. It only means a full 360 if n is an integer, so you have to state that. Okay. So in each of the cases, answer the following questions. Determine the angles in between minus 360 and which is coterminal with the given angle. So find the sets of angles that are coterminal in between minus 360 and 360 if 285 is a starting point. Okay, so find the family of angles for each of those. Go. So if you've completed example 3, the two angles, the angle that was coterminal to 285 was minus 75. If you add 360, you go too far. For minus 13, if you were to add 360, so you're just trying to get back to another, you get 347. If you subtract 360, you're too far. The principal angle is 347, so 347 plus n 360 represents all the possible angles. And lastly, 395 already has an extra rotation, so if you subtract 360 from 395, you get 35 degrees. If you subtract 360 again from that, you get minus 325. So there's two coterminal angles there. And the principal angle is 35 plus n 360, where n is an element of integers. Okay. The last thing to review is reference angles. And as you can see, a reference angle is formed between that terminal arm, remembering from Math 20. So a 120 degree angle has a 60 degree reference angle, right? And that 60 degree reference triangle, as we talked about in Math 20, can be put in all quadrants. It could be in quadrant 2, and then there'd be a 60 there. And it could be in quadrant 4, and there'd be a 60 there. And then the angles of theta would be 240 in quadrant 2 and 300 degrees in quadrant 4, okay? So in each of these cases below, they're talking about, well, what would be the reference angle? So you always have to look at the x-axis to determine, well, what is the reference angle? So a 243 degree angle, a 243 degree angle is actually 63 degrees more than 180 because I took 243 subtract 180. When I'm in quadrant 4, 337 degrees is 23 degrees less than 360. So 360 minus 337. It's never a negative angle. And obviously 70 degrees in quadrant 3 is just a 70 degree reference angle because when you think of making a reference triangle, it's always to the x-axis, right? And there's a diagram talking about how we can calculate those values. Whoopsie. So example number 5, state the reference angle of each, right? For 195, that's a 15 degree reference angle, and I'm going to draw these reference triangles every time. That is a 15 degree reference angle in quadrant 3. For minus 258, that comes around and that makes a 78 degree reference angle in quadrant 2. For 810, that's a lot of rotation. Somebody's getting sick there. But if you spun around that much, right, in a negative rotation, right, you would be minus 360, minus 720, and 90 degrees more. So that is a 90 degree reference angle. And lastly, this is about taking your special triangle and rotating it all around. It says determine 4 angles between 0 and 360 which have the same reference angle as a rotation of 128. So 128 has a 52 degree, minus 128 has a 52 degree reference angle. So now I put 52 degrees in all 4 quadrants, and that creates 52, 128, 232, and 308 degrees. And that is the basics to angles in standard position. Okay, complete assignment 1, math 30-1.